Mars was supposed to be the planet that lost everything. A dead world, a frozen desert, a surface blasted by radiation for billions of years. The kind of place where fragile chemistry should not survive, where any meaningful trace of the past should have been erased, long before humans ever built a machine capable of reaching it. But NASA's Curiosity rover just found something that makes Mars feel different again. Inside ancient rock, Curiosity detected a surprising variety of organic molecules, chemical remnants tied to carbon, the element that sits at the center of life as we know it. This is not proof that life once existed on Mars. That would be the easy headline. The real story is more disturbing than that. These molecules were found in rock around 3.5 billion years old, preserved on a planet that should have destroyed evidence like this ages ago. And that means the silence of Mars may not be as clean as it looks. Because if the red planet could hold on to chemistry this delicate for that long, then maybe Mars did not erase its past. Maybe it buried it. Maybe what Curiosity found is not an answer, but a surviving clue from a world that once looked nothing like the wasteland we see today. For a long time, Mars gave scientists only fragments, a promising signal here, a mysterious molecule there. Enough to keep the dream alive, never enough to force the question into the open. This discovery feels different because of where it came from and how it was pulled out of the rock. Curiosity drilled into ancient bedrock at a place called Mariana in the Glen Torridon region of Gale Crater. That area matters because it is rich in clay minerals, and clay is one of the best natural materials for protecting ancient chemistry. Billions of years ago, this was not the Mars we imagine today. It was a wetter world, and parts of Gale Crater likely held lakes and sediments where the raw ingredients for complex chemistry could settle and be preserved. Then Curiosity used one of the most delicate chemical tricks ever attempted on another world. Inside its onboard laboratory, the rover ran a special wet chemistry experiment designed to break tougher carbon-bearing material into smaller molecules that could actually be detected. What came out was the surprise. Not one simple compound, not one isolated hint. A diverse set of organics, enough to tell scientists that ancient Mars may have preserved far more of its chemical history than anyone expected. That is what makes this story dangerous for the imagination. Mars is no longer just a planet that once had water. It is starting to look like a planet that may have kept part of its old chemical record hidden in plain sight. And this is exactly where the story becomes stronger by staying honest. NASA did not announce life on Mars. The researchers themselves are careful. Organic molecules can be produced by biology, but they can also be produced by geology, chemistry, and even material delivered by meteorites. So no serious scientist is claiming this as proof of ancient Martian life. But that does not make the discovery small. It makes it more important, because the real breakthrough is preservation. Mars was expected to be brutally bad at holding on to fragile chemical evidence near the surface. Yet Curiosity found a richer mixture of organics than many expected, preserved in rock dating back roughly 3.5 billion years. That changes the emotional weight of the planet. It means Mars may still be carrying buried records from its warmer, wetter age. And this did not happen in isolation. In 2025, NASA announced that Curiosity had identified the largest organic molecules yet found on Mars, including decane, undecane, and dodecane, compounds that may be fragments of fatty acids. Then, in early 2026, NASA highlighted a study arguing that the non-biological processes tested by researchers did not fully explain the abundance of organics in one Martian sample. That still falls far short of proving life, but it pushes Mars away from the old idea of a chemically dead world. The picture is changing. Slowly, cautiously, but unmistakably, Mars is becoming harder to dismiss. If you are enjoying this story, subscribe now and hit like before we get to the part that changes how you see Mars. Because the deeper this rover digs into the red planet's past, the harder it becomes to believe that this world was ever as empty as it looks. That is why this matters far beyond one rover and one headline. Curiosity was never sent to Mars to make a dramatic television reveal about aliens. It was sent to answer a harder and more respectable question. Was ancient Mars ever habitable? Could it once support the kind of environment where life might stand a chance? And after years of climbing, drilling, sampling, and surviving in a place built to destroy evidence, the rover keeps pushing the answer in the same direction. Ancient Mars had water. Ancient Mars had sediments that could trap and protect chemical material. Ancient Mars had carbon chemistry complex enough to survive for billions of years in rock that should have been sterilized by time. That does not tell us that life happened, but it tells us the case is not closed. Not even close. And that is where the story stops being comfortable. Because if Mars kept these traces alive this long, then the next great discovery may not be about finding something entirely new. It may be about finally recognizing something that has been there the whole time, half damaged, half buried, waiting for better tools and smarter questions. Ability is not that Mars is alive now. It is that Mars never fully erased the evidence of what it used to be. And now, after billions of years of silence, an American machine is teaching us how to read the parts that survived.